this. And we just started. Okay, so here we are thinking about the wonderful world of our perfect packet staple company. All right. And just remember what we used to do, right? We're picking up papers, we're stacking them. Wait, I can actually stack them. And then putting the, staple in. So there's our perfect packet staple company. And we remember that as we produced output, right, we had a marginal product curve and a quantity of labor, right? And initially, as we hired new workers, we got better and better and better and better. But eventually, we ran out of things for these workers to do. And so those workers started getting less and less marginally productive. And eventually, we hired the people like, well, let's not call Ethan Fuller out, but oh my God, Ethan's here. Oh, that's so awkward. Sorry, Ethan. But eventually we keep hiring workers and we actually get less output from them. Okay, so what we know is that long run and short run have some analogies to them. The terminology is different, but the ideas are the same. Food over there, help yourself, grab a chair wherever you want. There's knives on the sideboard. There's cream cheese, butter, peanut butter. You can heat that up in the microwave if you want. There's also a toaster. Coffee is in the carafe there, and glasses are there. Cream is in the refrigerator, sugar's next to it. Okay, so here's the deal, right? This part of our marginal product curve is where we are seeing specialization and division of labor. We are getting better because we're adding workers. So here's our specialization and division of labor section. All right. Now, we reach a peak in this graph, and then we start to see that we are still getting positive outcomes from these workers, right? Because our marginal product is greater than 0. So we're still getting positive outcomes from these workers, but our positive outcomes are getting smaller and smaller and smaller. What's another word we could use for smaller and smaller and smaller? Aside from Sarah Taub, Suhana Bell, Kennedy, and Jada Carter. Smaller and smaller and smaller, right? Diminishing. See, because they're getting shorter as I named humans there. Did you see how that worked? Okay, yep. So this section over here is our diminishing. And what are we talking about? Marginal product, right? So this is our diminishing marginal return. And then we get to the Ethan section, right? And of course, once we cross that 0 line, what are we going to get after that? That's negative marginal return. Now, I have never in my life seen them ask anything about negative marginal returns on an AP exam, but just in case they do, you now know it. And in our world of the perfect packet staple company, that which we enjoyed so much, we then took that marginal product curve and we turned it into a marginal cost curve, right? As your workers become more and more and more productive, the output they produce costs you less and less and less. I'm noticing that that graph isn't on the page. Okay. So as we produce more and more output and our workers become more and more productive, our costs for each of those units of output go lower and lower and lower. So when marginal product increases, marginal cost decreases. And the minimum of marginal cost is the maximum of marginal product. And so here is our marginal cost curve. So if you are asked on the exam to say, you know, explain the shape of the marginal cost curve, what is your explanation going to be? Here is our specialization and division of labor segment. And on the right-hand side is our diminishing marginal return segment. Okay, so there's what your marginal cost curve looks like. And that marginal cost curve drives all of the other cost curves in the short run. If they ask you to explain it, one of two things will have happened. They will have asked you to draw a set of cost curves, or they will have given you a set of cost curves. So that might, like, one of the ways I've seen that question, and this is good, Goatmar, see? There's a reason we call him the goat, right? It's this right here. What are you looking at, Tob? Oh, wait, no, I didn't want to do that. Okay, so it'll look something like that maybe on a test where they'll give you something along those lines and they'll say something like, explain the shape of curve number 1. Or how might you find average fixed costs from this graph? How would one find average fixed costs from this graph? It's the vertical distance between 2 and 3. Very good. So it's 2 minus 3 at any given quantity, right? Because curve 1 is marginal cost, curve 2 is average total cost, and curve 3 is average variable cost. And fixed costs are the difference between total and variable. If we wrote that out as algebra, which I know you guys all enjoy, I occasionally go into Miss Schaefer's class during second period, and I see the wonders of algebra happening there all the time. It's really fun. ATC equals AFC plus ABC, right? Our total costs are our fixed costs plus our variable costs. Can we all agree to that? Let's do some math now. This is fun. If I subtract AVC from one side, what do I have to do to balance the equation? Subtract it from the other side. ATC minus AVC equals AFC. Okay, so there is why we know that average fixed cost exists between average total and average variable. And of course, a subtraction on a graph is simply the vertical distance between those two lines at any given point. Okay, so there are your average fixed costs. That's fun, isn't it? Good times, good times. AFC, AFC, AFC. This is something that gets confused all the time on the exam, so I'm going to point it out to you. Fixed costs do not change because they are fixed. Average fixed costs change because there's a denominator, there's an average, right? So let's just take a pretty picture, a quick look at why that is true. So if I told you that total fixed cost equal $1,000, I'm going to make the math easy for you, right? At quantity equals 1, Kennedy, I'm going to give you this one. What are my average fixed costs at quantity equals 1? What? Nailed it. You totally nailed that. I love it. 1,000. Okay. Let's go with Anusha. What are my average fixed costs at quantity equals 2? 2. I almost died.
Would it be what 1,000?
Close. That's total fixed costs. What are average? I get to divide my total fixed costs by the number of products I come up with. So
500?
Winner, 500. I'm going to keep this real easy. Hirsch, what's my average fixed cost at quantity equals 4?
250.
You're nailing it. So even though the total fixed costs is a constant number. Average means I'm taking the total and I'm dividing it by the number of things I create, okay? This right here is the short run version of what's going to create economies of scale in the long run. Economies of scale is simply size. Scale and size are the same thing, right? So how is it that I could keep lowering and lowering and lowering my costs? So if quantity equals 1,000, what are my average fixed costs? $1. Nailed it. Okay, so you can see if I make one of whatever this product is, I've got $1,000 worth of fixed costs that I need to cover in that one product. But as soon as I make 1,000 of those things, I've only got $1 of fixed costs to cover when I price that product. So you can see how making more and more and more of something allows you to drop the price lower and lower and lower and lower and lower, like Gillen's grade. Okay, now, oh, see, is that too much? Is that too much? Okay. Yeah.
Mr. Dollar,
Yes.
so is that why the vertical distance gets smaller and smaller?
Ladies and gentlemen,
Because it
let's
keeps
a little round of applause for Hirsch Mather, everybody. Hirsch Mather. That is 100% correct. That's why the vertical distance between ATC and AVC gets smaller and smaller and smaller, because we are dividing up those total fixed costs by a greater and greater and greater number of units of output. Hirsch Mather, everybody, what a delight. You're a peach, Hirsch. Another round. Yes, Julian, yes. All right. So that, ladies and gentlemen, is our short run version. We could call it the JADA run if we wanted to, of production. And one of the things that we know about that short run of production is that we have a minimum of one fixed input. So if we go back to the Perfect Packet Staple Company, we are looking at a place where we had one table and one stapler, right? And we kept adding more and more units of labor to that one table and that one stapler. We experienced our specialization and division of labor driving our costs down. And then we experienced diminishing marginal returns driving our costs up. And what we came out with was a marginal cost curve that looked like this, and an average total cost curve that diminishes until it hits marginal and then rises afterwards, okay? But that was our one table, one stapler world. Jack McCarthy.
The name of when it hits, is it allocated efficiency when the marginal cost, like when the benefit derived from one additional worker is equal to like one, is that?
Yep. Okay. Where did my coffee go? So what we know is that, again, this is our one table, one stapler world. But while we were doing this, we kind of agreed as a group that once we got those 8 or 9 employees trying to work at that one table, one stapler world, I then opened up a question that said, hey, what if we could have 2 tables and 2 staplers? Could we get better? And universally, you all said, yes. Yes, we could. Unless we hire Mahi, we're all good, right? You're not even remotely awake, are you? Do you want to? All right. Did you want a cup of coffee or something? Maybe some tea? Hot chocolate? Okay. Yep. Bruh. So here's our thing, right? LRATC, long run average total cost. So now we are into the Julian average total cost, or the long run, because he's tall. Get it? We're out of the JADA run. We're now into the Julian run. All right. And the difference between this is that in the long run, all of our inputs are variable. So we can add a second table and a second stapler, right? We can add more units of labor even in the short run, but in the long run, we can change everything. So what we're going to see is right over here, we have our one table, one stapler world that we started with, and that mimics this average total cost curve right up here, correct? However, we all agreed that if we added a second table and a second stapler, not only could we produce more, but we could produce it cheaper. So this becomes our two table, two stapler world. And we decided at one point that if we could find good enough employees, if we could find good enough tables that didn't have the Jimmy leg going on, if we could find staplers that didn't jam up all the time, we could even add a third table and a third stapler and get our costs to drive down even more. But here comes our next however. However, we did agree at one point that there would be a point where we aren't going to be able to find quality tables, quality staplers. We're going to have to hire people like Jack McCarthy or Anna Gibbs. And then, I mean, think about that as a process, right? These are people we don't want to hire. Jack's not good at taking directions. We've seen that, right? Jack is an oppositional human being. If he is told how to do it one way, what's going to be his goal for the entirety of his shift trying to work at the staple company? I'm going to waste time trying to figure out how to do it better so I can prove you wrong. Does this sound about right, Jack? Kind of nailed it, didn't I? So eventually we're going to hire some workers. We're going to get some jamming staplers. And even though we get bigger, we're not going to get any better. Okay. And so our four table, four stapler world isn't better than our three table, three stapler world. On the other hand, it's not worse, is it? Okay. And we try again and we get a five table, five stapler world here. And then we get to the dregs of society, right? Now we get to like hiring Sarah Taub. And as we hire Sarah Taub and we have those terrible staplers, you know, the ones that jam up all the time and you got to constantly open them and dig out the staples that are broken in there. Now we start our upward climb of our average total cost curve. And so our six stapler world is no bueno. Now we are going upwards with our average total costs. Now, is it possible that you can still be profitable at this point? Yeah, absolutely. If the price is still greater than average total cost, even though your costs are going up, sure, you might still want to produce at that seven table, seven stapler world. It depends on how much you can charge. So none of these places is better than another because we don't know the price of the product just yet. But what we do know is in the beginning of our world, we are going to see decreasing costs. And those are as close to tangent as I can make them. Then we are going to see constant costs. And then we are going to see increasing costs. And that is your long run average total cost curve. Okay. And we're going to divide this also into segments. On the left-hand side, when you see our long run average total cost decreasing, economies of scale. Economies of scale, economies of scale. What? That was pretty good, Jada. Come on, no? That is called returns to scale. And on the exam, you will often see them reference a constant cost industry. Okay, a constant cost industry. And if you see a reference to a constant cost industry, what they're telling you is it doesn't matter how large or small the firm gets, their average total cost curve is exactly the same because they are getting returns to scale. If they make a bigger amount of output, same average total cost. Smaller amount of output, same average total cost. Okay. And of course, in this section, we have diseconomies of scale. Diseconomies of scale. What about debt economies of scale? No. Remember, Taub, I can only be as funny as you are smart. Try to keep up. All right. That wasn't bad, was it? It wasn't my best. I know that. I know that. But it wasn't terrible. Okay. If you see this phrasing on the exam, increasing cost industry, that means the firm is experiencing diseconomies of scale. If they produce more output, what's going to happen to their average total cost? It's going to go up. If they produce less output, what's going to happen to their average total cost? It's going to go down. The way that you will see this in the exam is it will talk about that sort of resource reallocation in perfect competition that we do, right? Hey, look, there are losses in this industry. Firms exit the industry and the additional firms that are left produce more output, right? So if they tell you it's an increasing cost industry and the remaining firms are going to produce more output, their costs are going to go up. Hey, there are profits in this industry. More firms enter the marketplace. Each individual firm produces less. If they're in an increasing cost industry and they're now producing less output, it means they're going this way and their average total cost will, anybody? Drop. Okay, good. You realize this is all to amuse myself, right? No, I'm totally amusing myself. I'm just not amusing you guys, except for Gibbs. Gibbs finds me hilarious. Okay, so let's go to the progenitor of this question, Jada Carter. Did this give you a good explanation of economies of scale, and are you more comfortable with economies of scale now than you were when you walked in? Does anyone else have questions on the idea of economies of scale? Top.
So that, like, this whole sheet is about economies of scale.
So let me sum up. In the short run, we have specialization and division of labor, and costs go down. Okay, then we experience diminishing marginal return. And what happens to our costs? They go up. Okay. If you were doing an old school SAT where they had analogies on there, which were always fun, specialization and division of labor in the short run is like economies of scale in the long run. Diminishing marginal return in the short run is like diseconomies of scale in the long run. And if College Board does what they normally do, which is try to test if you understand the specific terminology of econ, there probably will be a question that talks about decreasing costs and has both of those as options. Your job is to figure out whether you are in the short run or the long run. Hey, look, this firm has decreasing costs. It will tell you whether one of the inputs is fixed or whether all the inputs are variable. If a firm has decreasing costs with a fixed input, specialization and division of labor. If a firm has rising costs and all of their inputs are variable, diseconomies of scale, short run versus long run. Is that everybody good on that? Oh, okay. Threw a little curveball at you there, didn't I, Jada? Oh, all right. Again, I do this to amuse myself. Somewhere I wrote down what people wanted to talk about today, and there it is. Okay, so economies of scale, scratch, done. What I think I will do next is go through the idea of perfectly competitive markets and modeling perfectly competitive markets, because that's sort of where we started the year, right? With these ideas of the nature and function of product markets. So one thing we always remember is we have industry and firm. The industry is all of the firms together, and the firm is a representative firm within that industry, okay? So a market or an industry is always simply going to be supply and demand. That is always going to be your marketplace. So there's our Q, there's our P. One of the things we know about a perfectly competitive marketplace, when you think about the characteristics of it, so many buyers and sellers that nobody has price control. Free entry and exit into the marketplace. There are no barriers, so anybody can get in anytime they want. Information is symmetrical. We all have access to the same information. We all know prices. We all know product information. And probably most importantly, all the products are perfectly identical. So you have identical products. I can't tell who made it. And if you can't tell who created a product, what's the only thing that is going to be the determining factor for you and your purchase? Price. That's exactly correct. All right. If you hit this button, the air will actually come on for 30 minutes. Let's hope, because it's getting real hot in here. All right. So because no one has price control and there are so many buyers and sellers in the marketplace, the representative firm in the marketplace has no control over the price. So what price do they charge for their product? Anyone? The market price. Yes, they charge the market price. So this becomes the demand curve for the firm, because people are only going to be willing and able to participate with that firm at that one price. Okay, so that's why this is the demand curve, right? And it's also our friend. Who's our good friend? Mr. DARP. That's right. Marginal revenue, demand, average revenue, and price are all contained right there. Why? Marginal revenue is the additional revenue I get from selling one more product. If every product I sell is $5, what's my marginal revenue from the last one? How about the next one? How about the one after that? How about the one after that? And if I sell all of my units for $5, what's the average that I bring in for every unit? $5. Do you see that? That's where Mr. DARP comes from. That's why he's our friend. It represents people's willingness and ability to buy. That's why it's the demand curve. It represents the value of sale of each additional unit. It represents the average of every unit sold. Oh, we lost somebody. How sad. And it represents the price at which it's sold. All right. So there's our friend, Mr. DARP. And now we can add in what we just learned about our perfect packet staple company, which is every single firm has exactly the same cost curves. So we add in our marginal cost curve. Good. Let me just randomly select someone here. Jada Carter, where will this firm choose to produce? At the profit maximizing quantity where MR equals MC. That is absolutely correct. Well done, Jada Carter. You are a treasure. Class of 2022 treasure, Jada Carter. Can we make a plaque that says that? Wait, what? Why can't we? All right. So once you establish that idea of where MR equals MC, it's kind of the only place on there we care about for right now, okay? So what I'm going to ask you to do is I'm going to ask you to draw an average total cost curve in there that creates negative economic profit. Another way to put that is losses. And I'm asking you to do that so I can fill my coffee cup. You know, you drink coffee. That's weird. Oh, hot chocolate we can make. Peppermint hot chocolate? Just regular hot chocolate? I don't Okay, we should all have drawn in something that looks a lot like this. Make sure your minimum point goes at MC. And there is our ATC curve. And how do we know these are economic losses? Because at the quantity where MR equals MC, what do we notice? ATC is greater than price. Okay, now here is where this is sort of a thing that you'll be asked to do on the exam. All right. So if perfect competition is the free response answer, the first free response, often they will have you do something like, now show the return to long run equilibrium. We know that in a perfectly competitive market, there are no long run profits or losses because the marketplace is going to reallocate resources for us. Those losses are going to have an impact on that marketplace. What I'd like you to do right now is demonstrate that impact on the marketplace on your set of graphs. Go. Think first, what are the losses going to do? What incentive are the losses going to create? And then show the impact of that incentive.
Yeah, it's just like, other than that, I'm not hired because of the international work.
If you move, if you do it backwards, it actually works easier from a drawing perspective. We're showing adjustment to long run. Think about the incentive in the marketplace. What's going to happen when those losses exist? Yes. Yes. Not only do I have one different colored pen tub, I'm going to give you a series of pretty ones. All right, I'm walking around, I'm checking things. Good, good. Normally they will tell you to show it on the same graph, but that is correct theoretically. Good. Transfer your price over. Good. Perfect. On your exam, you know what's going to happen and you know the outcome. Draw it backwards. Show the dark, draw the dark curve in and then transfer it over to the marketplace. Even though that's sort of reverse causation, it actually makes it easier to draw. Yes, yes. Go for it, making things happen. All right. I actually looked at it as I walked by. The only downside? Yeah. Which supply curve is 1, which is 2. Jack, labeling problems. What a stunning turn of events. Okay, so as we know, the losses in the marketplace will lead to firms exiting that marketplace. The incentive when there is losses, take your ball and go home, right? I'm going to take these resources and I'm going to reallocate them to something more profitable. I'm going to show you the little cheat trick here to make sure that on your exam, you get this drawn properly. We know that long run equilibrium happens right there. So let's just draw in Mr. Darp first. Give him a little star. Q star. P star. Good. Now we know that that must have come from the marketplace. So all we have to do now is show how did we get this new price? And what we see is that because there were losses in the industry, firms chose to leave the industry. Overall, the marketplace is going to produce less output because obviously people don't want this thing, right? Each individual firm in the marketplace now gets to charge a higher price because there's fewer sellers, and they will be able to produce more output. They get a bigger share of the remaining market because the firms that have left are no longer there competing with them. And there we have long run equilibrium. What is true? At the quantity where MR equals MC, price and average total cost are equal. Good times, good times. All right, now what you're gonna do is you are going to graph start to finish a firm earning economic profit side by side with a market and show it returning to long run equilibrium. Lauren, go ahead.
On the exam, from a graph drawing perspective, what is the, like, are they going to give us graph paper or do we do it online paper? And then are we going to have a ruler and that kind of thing? I'm just wondering like what it would look like.
You won't get a ruler, I don't think. The paper that you will get is exactly like every other AP exam that you take. So it's basically, you're just doing it on lined paper. You are drawing a market and a firm side by side. Start with the firm earning positive economic profits and then show it returning to long-run equilibrium. Everything's fine. I never did pour myself a cup of coffee. Yeah, I did. Yes, yes, I can. Can I even do like peppermint hot cocoa or just standard hot cocoa? That's easy. That's in there. That's done. Pour it in there, stir, add cinnamon. Yes, it makes it delightful. Okay, ladies and gentlemen, we wanted a firm returning positive economic profits. What that means is that at the quantity where MR equals MC, our price needs to be greater than our average total cost. Whee! Whee! Okay, there we are. So there, our price is greater than our average total cost. Price here, average total cost there. Okay. Now, what we wanted to see was a return to long-run equilibrium. So if there are profits in this industry, what's going to happen? More firms are going to enter. Yes. So which way to supply curve, Kennedy? Shifts to the right, Foshizi. Yes. Outstanding. Now, we're going to shift our supply curve to the right. We're going to label it with something different, correct, Jack? Excellent. Q star, P star, and we are going to transfer that new price over to our firm, drawing a clearly perfectly straight line. Mr. Darp, star. We are going to identify our brand spanking new quantity, and there we've returned our firm to long run equilibrium. And in essence, what we just saw was an example of how the price mechanism works in marketplaces, right? High prices drew high prices and profits drew firms into the marketplace to steal away those profits. On our previous graph, low prices and losses drove firms out of the marketplace, and resources were reallocated to what society most wants. And that is how the price mechanism reallocates resources to make us as happy as possible. And how do we know we're as happy as possible? Price equals marginal cost. The benefit from the consumption of the last unit is equal to society's lost resources. In essence, that's what a marginal cost is. Marginal cost is the cost of society's lost resources to make something. How much benefit should you get if society gives up resources? Exactly the cost of the resources. Give up $7 worth of resources. What do you want at least out of that product? Anyone? If you give up $7 of resources, what do you want at a minimum? $7 worth of benefit. And if somebody is willing and able to pay $7, that means they're getting at least $7 worth of benefit out of it. There we go. Okay, that's fun times. I'd like to do one more thing in the world of perfect competition here, which is just modeling and showing the shutdown rule and loss minimization. Sound good to everybody? Just a little recap, or for many of you, cap, I guess. You don't know how to pour, do you? Just there's a handle on the side. Do you see it? Lift, 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 lift. Good. Take the lid off. Yeah, good. Pour. 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 Oh God, pour fast. Oh my God. Oh my God. Brett.
Andy, I'm doing this for you.
Sure. All right. We just watched Sarah Taub attempt to pour milk out of a milk frother, and there was a level of success. Let's not describe that level of success. But I would say that Sarah Taub has a better chance of hitting a 20-foot jump shot than pouring milk out of a milk frother properly. All right. Does that seem reasonable as a statement, Sarah? Okay. So I'm going to draw us the cost curves for a firm. And if we're going to do the shutdown rule, we need an average variable cost curve in there as well. And as Hirsch so wonderfully pointed out to us earlier, the distance between average total and average variable changes all the way through because of the changing value of average fixed costs. Hirsch, you are a delight.
Thank you.
Is Hirsch still here? Yes, Hirsch is still here. Hirsch tried to say something but was muted, and that's fine. Unmuted, didn't say anything. Hirsch, are you there?
I'm there. I just
Okay.
said thank you for your kind words.
You know, I do what I can. It's all I can do, you know? All right. Okay. Let's examine why a firm might shut down versus exit the marketplace or loss minimize. Okay. So let's take a look over on this side of our world here. And I'm going to put that a firm can charge $15 for its product. Okay. Can you guys see that, or is that too light? You're glary. Is that better? Who can say? All right. So the price of the product is $15 and the average total cost is $18. Should this firm leave the market? Maybe. Are they losing money? Yes, they are. Okay. Now, what we have to figure out is, can they do better by staying in the marketplace and losing money, or would they do better by simply shutting down for right now? Okay, so I'm going to give you a couple other figures here, and we're going to figure it out. All right, so our average fixed costs for this firm are $6 where we're producing. Okay, what does that mean our average variable costs are? ATC equals AFC plus ABC. 18 equals 6 plus X. Good. You got good. That's so great. You guys are really nailing this. X, or average variable cost, equals 12. Okay. So AVC equals 12. All right. Now, let's take a look at what this firm can do. They're getting $15 for their product. Can they pay all of their variable costs? Yes, they can. How much money do they have left over after they pay their variable costs? $3, right? And that $3 can go to paying off a part of their fixed costs. Is that a reasonable statement? Good. So if they open up and stay in business, their losses equal $3 per unit, because these are averages, right? Because the $15, P equals 15, right? Minus $12 for average variable costs equals 3, minus $6 for average fixed costs, and we get to minus $3 per unit. Okay. Now, if they were to shut down and not bring in any money at all, they would still have to pay their fixed costs. And what are their average fixed costs per unit? $6. So how would they do if they shut down? Shut down equals losses of $6 per unit. What is better for them in this particular case? They should stay open and minimize their losses. Okay, what does that look like on the graph? Looks like this. All right. Where is this firm going to choose to produce? At the quantity where MR equals MC. Okay, here's the price they can charge, and I'm going to use the numbers from our example. So there's our $15 that they can charge, right? At that quantity, we know that our average variable costs were $12, and we know that our average total cost was 18. All right, let's get ourselves a pretty little highlighter. And this is me starting at a cost of 0 and going up. There is me covering $12 of average variable costs. And I haven't gotten to my price yet, have I? I have not. What do we know exists in between average total and average variable? Average fixed. Average fixed cost is the vertical distance between those two. So when I switch and I do this, this is me paying part of my fixed costs, correct? But is my price high enough to cover all of those fixed costs? It is not. And that is why, in this case, we are going to see losses amounting to $3 per unit. Okay, so what we have is covered fixed costs, right? This area is covered variable costs. And what is this part right here? Losses. Because our price isn't high enough to cover all of those things. Yeah. Yeah. Stealing milk, stealing my stirring fork. What a disaster it is around here. Oh. Okay. Now, we're going to do, has everybody got that down? Know what they have on here? Did that make sense? Are we good on that one? Seems so. Oh. All right. We're going to do one more, just like that. Sort of just like that. I'm aware, Gillen, that wasn't my best effort. Not bad. I've done better. Price equals $15. Average total cost equals $20. Average fixed cost equals $3. All right. So your job right now is to find average variable cost. Gillen, give me the answer. $17 is correct because 17 plus 3 is 20. Rocking out some HL math skills there. I love it. Good times. All right. So if this firm opens up, they're bringing in $15, correct? And then they pay their average variable costs. And then they pay their average fixed costs. And they get to losing $5 a unit. Does that make sense? Everybody good there? Okay, so this is open. If they shut down, oh boy. What do they have to pay per unit in losses if they shut down? $3 per unit, because all they have to pay is their fixed costs. Okay, so would you rather lose $3 or $5? 3. And so in this case, what is the better option for this firm? Shut down. Yeah. Now, what would that look like in our graph? There is Senior Darp right there. They would choose to produce, if they were going to stay in the marketplace, here, where MR equals MC. And let's do the same thing we did last time. I can cover that much of my variable costs. So this is covered variable costs. I pronounced that right, didn't I? Okay, good. Yet, ladies and gentlemen, here's our problem. At that quantity, we can see that right here. This is my $15 price. This is my $17 price. And here is my $20 average total cost. I can't even pay all of my variable costs, can I? Variable costs not paid. And of course, here to here, the vertical distance between average total and average variable, what is it? There's our losses of fixed costs, right? So this is fixed costs not covered. So in essence, what we see is that this pink box right here if I stay open, those are losses in excess of what I would have had if I just shut down. So what's the better plan? Just shut down. Because if I shut down, what's the only thing I lose? I just lose this amount right here, the fixed costs that aren't covered. Okay. So in our case, it was $3 per unit times whatever the number of units was. If I put 100 here, what are my fixed costs if that's 100? This is a good question, isn't it? Tal, what is it? What are total fixed costs if this quantity is 100? What's this? 3, right? How much is this? 3. There we go. We turned it into math and Tal got it immediately, right? So it's the area. How do you find an area? Base times height. So the height of this is $3. The base of it is a quantity of 100. So in this case, our total fixed costs would be $300. Okay. How much of our variable cost did we actually pay for? $15 times 100 units. So this green area would be equal to what? What's 15 times 100, everybody? 1,500. Great. You guys are nailing this. How much variable cost did we not pay for? What is the total value of variable cost that didn't get paid for? 200. It's the $2 between 15 and 17 times the 100 units. Base times height. Base times height. Base times height. It does, doesn't it? It's weird. It's very weird. Okay, so there are your shutdown scenarios. Jada, why do you keep stealing my things? Jada, you are, well, I don't know. I just feel like you're stealing my things. Okay. All right. So we also wanted to cover the concept of elasticity. Elasticity, elasticity. No, that's electricity. Right? Schoolhouse Rock, everybody. Okay. Whew. Tough crowd here. All right. So elasticity. Let's do this a couple different ways. Okay, there we, oh, okay. So let's set a quantity and a price in this market. All right. Now we are going to impose a per unit tax on this marketplace, and we are going to see the impact of elasticity as we impose a per unit tax. If we tax the suppliers, is that better, blindy? Christ. Trade in the Mercedes, buy a Hyundai, and pick up a pair of glasses. All right, so if you impose a per unit tax on a seller, what impact does that have on the marketplace? A tax increases cost of production, and therefore what's going to change? It will increase cost of production, shifting the supply curve left, or in this case, we can say up. So the supply curve will shift vertically by the exact value of the tax. For those of you that did externality IAs, you might have remembered that when you did your externality IA, you identified the value of the externality as the difference between the two curves. Same idea here. Maybe you didn't, maybe you did. Who can say? All right, so when we tax this product, we see that we change our quantity and we change our price. So there's our new equilibrium. And the one, oh. Okay, no, maybe, who can say? Focus different? I don't know. Better, worse? Don't use light blue. Okay. Ladies and gentlemen, I think this is, I think one of the genuine problems we're seeing with having Jada Carter back in the classroom, I think is this is. Okay, is that better? Can we see that better? Oh, all right. Now, what you will notice is that because the demand for this product is relatively inelastic compared to the supply, people are not going to move away from purchasing it, right? We see a very small change in quantity relative to the change in price. So we are seeing elastic. What in the name of all that's good and holy is going on with this camera? Hold, please. What if I lowered the resolution on it? Okay. That does show up better, doesn't it? Oh, all right, there we go. So lower resolution is better, apparently. Weird. Very weird. Now, we see that the relative change of price is greater than the relative change of quantity because people must buy this thing. This is the kind of idea where you get like addiction. Remember those determinants of elasticity? Splat, substitutes, proportion of income, luxury versus necessity, addictiveness, and time. Okay, splat. That's also fun to say. Now, what we want to do here is we want to see, and we can make a prediction about this as well. If people are going to buy the product no matter the price, who's going to wind up paying most of the tax? If people are going to buy the product no matter what the price is, who's going to pay most of the tax?
The
The
consumer?
consumers are, because you can simply pass along the tax to people who are going to buy this anyway. Could you, if you were an immoral jerk, really start taxing insulin really high? Yes, you sure could. And you could make a bundle of money by taxing insulin, because if people don't buy it, they diet. Get it? Oh, wow, that was fantastic. Whew. Jada, anything on that one? Too soon. Okay, fair enough. Imagine putting a huge tax on a coronavirus vaccine. That would be suboptimal, but you could make a lot of money off of it. So now what we're going to do is we're going to identify the value of this tax, and we're going to see the split in tax burden, right? The value of the tax is the vertical distance between the two supply curves. And we're going to identify that on our axis as P0. Did the price of the product change by the full value of the tax? Price used to be here. Price is now here. Is that the full value of the tax? It is not, because the full value of the tax is the difference between P tax and P0. So here is the increase in price. Here is the part that didn't get accounted for. So who's paying the increase in price? Consumers. So here is our consumer tax burden. And if the consumers are picking up part of this in the form of a higher price, who's picking up the rest? Producers. There's the producer's burden. Okay. So if you have an inelastic product that people are going to buy anyway, gasoline, insulin, you can tax those products because you can pass the tax on to the consumer pretty easily, and people are going to buy it anyway. You do see a few demanders who are kicked out of this marketplace. We do lose market participants in this. Those market participants, I'm dying. Those market participants lose consumer surplus. Producers lose surplus, and this area is deadweight loss that shows inefficiency in the marketplace because of the tax. Jack, you had a question.
Kind of answered it. You talked about consumers.
Okay.
I was wondering if they were like similar.
Yes. The inefficiency that's created changes the surplus, but yes, they're in there. Okay. Guess what your job is now? You're going to draw a graph with relatively elastic demand, and you are going to identify the tax burden as you tax that relatively elastic product, like Skittles or hot chocolate, because they're substitutes like coffee and tea. I will wander around and see what's what. Are you done yet? Oh wait, that was. Yes, show the tax. I like it. Good. Yes. You can tell the difference. Ready? Label and show the burden. Speaking of burden. Yes, perfect. Yes. tell you something that is a good lesson for the AP exam, right? Big graphs. Make it easy for the reader. Yes. As I was wandering around, you may have heard a quick thought that we had. Big graphs on the AP exam. Make sure that you're not like forcing the reader into like, oh, is that area labeled this? Is it that? Don't give them any reason to avoid awarding you points. Okay. Oh. 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 All right, so here's our supply curve, and we wanted a relatively elastic demand curve. And we're going to set a price and quantity. Yay! Whee! Okay, good times. All right, so we are going to tax the suppliers in this case, and we are going to shift the supply curve vertically by the value of the tax, which will give the government stacks, because now they're collecting revenue in cash. No? I don't understand how all of you missed whatever humor gene is out there, because these are pearls here that I'm dishing out. Just pearls. Okay. Stacks, get it? Lots of money because they're taxing and collect. Okay, Dylan, how do I identify the value of the tax? That's correct. We're going to highlight that over on our axis as P0. Did the price rise by the full value of the tax? It did not. No. So here is our consumer burden going that way. And here is our producer burden down here. And there is what happens when you have an elastic good. And could someone explain to me why the producer has to pick up a little bit more of the tax when you have an elastic good? Loud and proud? That was neither loud nor proud, but you're correct. If you change the price too much, people won't buy it. And we can see it right on the graph here, right? We have this tiny little change in price from P to P tax and a relatively larger change in quantity demanded at that same time. So if you try to raise the price too much, you're just going to drive your customers away. So in that case, the producer is going to pick up the tax burden because they can't really pass it along. It's why we don't tax things like Skittles very high. Why? Because people would just buy Necco wafers. Literally no one would buy Necco wafers. It's the worst candy on the planet. They're awful. They're chalky grossness. People would buy Spree is what they would do because everybody likes Spree. They look like communion wafers, says noted Catholic Jada Carter. I'm kidding. All right. You know what I'd love to see you do? I want to see you draw a graph where the tax burden is split evenly. Go. Draw a graph where the tax burden is split evenly. And also, what's I don't know if it was Thursday. You're gonna do that on the exam, and you're gonna be so mad.
Make sure you don't know what a price action is.
I'll tell you what, it's the dumbest reason ever to use points on an exam. Isn't it? Really enjoying being here, aren't you, Jada? Who can say, really, right? Okay. In essence, when you are drawing something where you want the tax burden split evenly, what you want is the relative elasticities to be the same. That's all you need. So the slopes should be sort of like -1 of one another, if that makes sense. Q and P. Our supply curve shifts vertically by the value of the tax, and the government makes stacks. Okay. Whew. Q tax and P tax. If you draw these properly, your relative change in price and quantity should be about the same, right? We identify the vertical distance between the two supply curves as the value of the tax. And we can see that our consumer burden and our producer burden are roughly equal because the elasticity is roughly equal. Okay, Jack, did that help answer your questions on elasticity? That makes me happy. The last thing on elasticity that often shows up on the exam is in the monopoly market. And the question of where does the elasticity change, or when this firm is producing, pick your poison here, right? If it says, if the firm is producing at the profit maximizing output, there we go, Q pi, P pi. Is this firm producing in the elastic or inelastic range of the demand curve? Our answer is, in this case, elastic, because MR is greater than 0. Another thing they could ask is, if this firm was producing at the allocatively efficient output, would it be in the elastic or inelastic range? That's asking you to know two things. So allocative efficiency is where price equals marginal cost. So there's our quantity of allocative efficiency. Are we in the elastic or inelastic range there? We're in the inelastic range because marginal revenue is less than 0.
But doesn't that one depend on like how steep the marginal cost curve is?
Yes, it sure would. Absolutely. And that's one where they would only ask that on a pre-drawn graph. So they wouldn't have you like draw a graph and then ask you that question, because that would be a different answer for everybody depending on how they drew their own graph. And they would never ask the readers to make that sort of connection. So they will only ask that question on a pre-drawn graph. And yes, you can have an allocatively efficient outcome, which is elastic in the range as well. Depends, again, like Sam said, on the slope of the marginal cost curve. Oh, okay. What's that?
What does that mean? Like,
Oh, it doesn't really mean anything. It just it's a question they ask to test your understanding of what marginal revenue means relative to elasticity. It's that total revenue test idea. If price and total revenue are moving in opposite directions, elastic. If price and total revenue are moving in the same direction, inelastic, right? I always say, whenever you get an elasticity question, think about products and it will make sense to you, right? Think about the idea of insulin. If the price of insulin increases, are the sellers going to make more money or less money? More, because people are going to buy it anyway. If the price of insulin decreases, are sellers going to make more money or less money? Less. So price and revenue move in the total, let me try that again. Price and revenue move in the same direction. And we know what type of product insulin is. What type of product is it? Inelastic, because if you don't buy it, you're not going to be happy. Okay. See, I didn't make the same joke that time, Jada. Did you? Oh, I got applause from Jada. Now, sure, it was just a tiny little golf clap, but really, it was so validating. Excuse me. That was awkward, wasn't it? Okay. Yeah. Okay. I'll maybe try to stop crying. All right.
So for these
Yeah.
marginal revenue questions, when we if we actually get one and it has is it elastic, explain, is it okay if we just write yes or no and then MR is greater than or less than 0 and no matter who the reader is, they'll be fine with us not writing a sentence?
100% correct. Yes. Okay. Suhana, what is bothering you? You're cold? What's happening? All right. What I'd like to do now is draw monopolistic competition in long run equilibrium. So draw me a monopolistically competitive firm in long run equilibrium. Equilibrium. I'm going to wander around and take a look. Yeah, you're not done yet.
What do you want from me?
Monopolistic competition. It's a short ruler. Really stupid. Jada, Napoleon? Short ruler.
Yeah, like me.
Oh, I didn't even make that connection. Anybody else? Ruler? Ruler? Does that help? Okay. We are looking for a monopolistically competitive firm in long run equilibrium. Now, the reason that a monopolistically competitive firm can have a long run equilibrium is because low barriers to entry. Look at Julian, just knocking it right out of the ballpark. You know what? It's really, honestly, a little unfair, Julian. That smart, that handsome, that talented. Maybe save some for the rest of us, right? Okay. There's our quantity and price axes labeled nicely, right, Jack?
Yeah.
All right. We know that our demand curve is going to be downsloping because of product differentiation in the monopolistically competitive market. In order to sell more units of output, you are required to lower the price. And therefore, marginal revenue will slope down faster than demand. We have a marginal cost curve that looks exactly the same as all of the other firms because we don't care how you sell output, you produce it the same way every time. Where will this firm choose to produce? Where MR equals MC. There's our quantity of profit maximization. We go the demand curve to find our price. Excellent. Now, long run equilibrium means that at the quantity where MR equals MC, price and average total cost are the same, equal. So here we are drawing in our average total cost curve that has a point of tangency there. Its minimum point at MC. And there we go. I'm not going to lie. That's not bad. That's not. Oh my God. There might be a little more tangency, but it's not bad for freehanding it, right? All right. So there is your long run equilibrium position. All right. Now, other ways that they'll talk about monopolistic competition on the exam. All right. They like to use the phrase excess capacity. Okay. And excess capacity is relative to this point right here. Okay. What is that point there where we're hitting the minimum of our average total cost curve? That is productive efficiency. Yes. P equals minimum ATC is also called productive efficiency. I think that was on B-Day's test the other day. Yes. Is this firm operating at productive efficiency? The answer was no, because it wasn't at minimum ATC. The reason that monopolistically competitive firms are said to have excess capacity is because their profit maximizing point is actually at a higher average total cost than their minimum. If they were to produce more output, what could they do with their costs? Get them lower, but they don't choose to because it's not profit maximizing. So this is why this firm is not efficient from a production standpoint. Julian, loud and proud. 100% correct, Julian. You cannot be productively efficient if you have a downsloping demand curve. Look at you. Mostly because those intersections can't happen in that particular case. So this firm will never be productively efficient. And from society's perspective, we are now paying a price that is higher than marginal cost, and we are paying a price that is higher than the minimum of average total cost. Okay. In the IB world, they might ask you to make comparisons about like perfect competition versus monopolistic competition. And in the IB world, you could say something along the lines of, we actually don't mind paying these extra costs. What is it about a monopolistically competitive world where we don't mind paying the extra costs and having that inefficiency? What do we get?
Differentiation.
Differentiation, right? We get differentiation. If we wanted perfect efficiency, we would have to have perfectly competitive markets, which means every t-shirt, exactly the same. Every car, exactly the same. Every house, exactly the same. And how would I let my neighbors know that I am better than they are if not for driving a nicer car? How do I let my neighbors know that I am better than them if not remodeling my kitchen, right? This is the thing. It's not that I like it. It's that I need to let other people know that I'm better than them. So I product different. I'm kidding. All right. So the idea, of course, is in the IB world, when you write about things like this, if they ask for a comparison between perfect competition and monopolistic competition, you can actually make a reasonable argument that says, we actually don't mind this inefficiency because we get choice. And the choice that we get is a nice trade-off for the inefficiency of the marketplace, right? Since you don't really have to write all that much on the AP exam, you'll probably not have to go into that kind of depth. But just knowing that that's out there is a good thing because it'll help you next year. And that. All right. Sounds good, doesn't it? Do we want to take like 5 minutes right now and just like stretch, go to the bathroom, do things we need to do, or should we keep? Looks like a lot of head nodding yes in here. So let's take 5 minutes. Get food, get drinks, get yourself together, whatever you need.
On the AP exam, will we have like as much space as we'll have for like essays, like the long essay, or will we have, like short answers?
Yes, you will have more than enough paper. That is for sure.
Wait, could you go over like the parts of the AP exam again, like the multiple choice and free
Yeah,
choice?
when we come back together, I will absolutely go over those.
Sure, thank you.
Yes. Game theory basically works best if we just like do practice with it. Hi, everybody. Are we back? Probably could have paused the recording during that, but yet I did not. All right. Okay. Where were we going after this? I don't know. Like I said, I'm going to go until we are done. Oh, okay. So I imagine we're fairly comfortable with the idea of graphing a monopoly. Okay. So I think what I'm going to do for those of you who, decided to show up today is do a little preview of class on Monday so that you get to see things twice, which is always more helpful in learning things. I always remember my calculus teacher in high school. I grew up in New York, as you guys may remember me mentioning once or twice, and we started school the first week of September instead of the first week of August. So we were a month behind always. But my calculus teacher in high school had this theory that you never learned anything the first time you saw it. It was always twice. So we finished the entirety of the AP calculus course between September and the first week of February. And then we did it again. And so it was pretty interesting. But on a positive note, everybody who took his class got 5s on the AP exam, so that worked out well. So a needle pulling thread, la, no to follow. So let's ask ourselves a question. Let's imagine just for a second that we have this marketplace. Let's zoom out a little bit. And can we see this okay? No, sure can't. What is happening? Brohammer. All right, so we have a quantity here, okay? And I'm gonna put a nice W right up there. And what do you think that W is for? W. A wage weight. Yes, it's a wage weight. Yes, it's the wages that you get from going to work. This Jada finds funny. What? Maybe I am. All right. So would we agree, and I love your discussions on this during your practice test when you guys all got to talk about it. More people will be willing to work at higher wage rates. Okay. I would imagine if I offered each of you $3 an hour to come to my house and rake leaves in my yard, I don't think I'd get a lot of volunteers for that, would I? What if I offered $300 an hour? Exactly. Yeah. What time am I there? Right. You just give me the address and I'll show up. And that's sort of the idea of the supply of labor, right? As you raise wage rates, by the way, I'm going to screw that up because I do have a mild speech impediment that creeps in every now and again, and I will say, raise the wage rate without even trying. It's just going to happen. We're going to muck through it and everything's going to be fine. All right. So as you raise the wage rate, you get more people who are interested in working. Does that make sense for everybody? Okay. So our supply curve of labor is an upsloping line. I'm sure there is a price where Bill Gates would even get off of his couch and come rake leaves at my house. I don't know that I can afford that price, but I would assume it exists. Bill, I'll pay you $74 million an hour. Think Bill would come and rake leaves at my house? Maybe. Maybe not. Well, he did just get a divorce and he, maybe he's a little tight for cash at the moment. Who knows? Now, all right. Not buying it, Jada? Okay. So when you guys were discussing during your multiple choice test together, this question is often asked as work is a trade-off between wages you can earn and free time. That's exact leisure, right? Because the opportunity cost of going to work is the free time that you had not working, right? And so work is a trade-off between the money you earn working and the leisure time that you could have had. We all have different amounts of money that are required to get us off the couch, right? Or different costs in this case. Obviously today, maybe some of you were drawn here by a bagel, maybe a cup of hot chocolate, right? Who can say? Some of you were drawn here by learning. Some of you were pushed here by mommy and daddy. Who knows, right? But for whatever reason, you got off the couch and came here, as did I. God bless America. What is my cost of being here today? Hitting golf balls, probably. Yeah. What's the benefit of me being here? Literally nothing. Literally, I'm not getting paid a single dime to be here. And not only am I not getting paid, what's that? I bought the food to bring. Yeah, okay. So negative $25 to come here and do this. All right. Oh, yes, the benefit of my students being more successful on the AP exam. There we go, Jada. You're pointing out the positives. I already get the highest grades in the county. Now, hey, I wish I were kidding. I'm not. Now, here's the thing, right? Let's look at the other side, or let's think first. Who are the suppliers of labor? People, we are. Households are the suppliers of labor. So, unlike the markets we've been looking at before, where the businesses were the suppliers of products and services, we are now the supply of labor, okay? Well, if we are the supply, who's the demander? Firms are. And can we agree that firms would be more willing and able to hire labor at lower costs? Sure. So that's why we have a downsloping demand curve for labor, okay? And that in the marketplace sets an equilibrium quantity and an equilibrium wage rate. There we go. Caution, got it right. Wage weight. All right. Now, if this is a perfectly competitive market for labor, what do we know about perfectly competitive markets for products? What are some of the characteristics of a perfectly competitive product market? Everything's identical. No barriers to entry. So many firms and actors in the marketplace that nobody has price control and perfect information. The exact same thing applies in this particular case, right? What we're talking about for perfectly competitive labor markets is in essence unskilled labor, right? Where literally anyone could do it. Yes, you could even put Sarah Taub out there and she could do it. So we're looking at unskilled labor here where every person is in essence identical. I don't care who I hire because everybody's exactly the same. So if we have a marketplace where there are so many buyers of labor, so many sellers of labor that no one has control over the price, and every person in that marketplace is in essence exactly the same, what do you think the firm is going to face here as a supply curve? A straight horizontal line. That is 100% correct. Why? Because as long as I pay the market wage rate, how many people can I hire? As many as I would like, because there are so many people out there and they are all exactly the same. And of course, because this is econ, we have to give everything stupid names, right? The supply curve equals MRC. And you might ask yourself, what's MRC? Nailed it. Yes, it's marginal resource cost. And by the way, I would just like to point out that like that right there actually is a demonstration of just things you've learned this year. And the idea that if you are comfortable with the economic way of thinking, if you see MRC and you know the marketplace we're talking about, that makes sense, doesn't it? What are we talking about? The extra cost of hiring one more resource, marginal resource cost. Nailed it. Good. All right. So our supply curve is equal to our marginal resource cost because I can hire anybody I want as long as I pay that market wage rate. Why would I be willing to pay somebody $5 to come and work for me? Loud and proud, Jack.
Because you're getting at least $5 of benefit.
That's perfect. That is exactly the reason I would want to hire someone. I demand labor based on the amount of revenue that they can generate for me. I will pay you as long as you are profitable for me, right? If I pay you $5, you better give me $5 worth of output. If I pay you $10 an hour, you better give me $10 an hour worth of output. All right. So I'm going to rewind just a little bit. We're going to travel back in time. Okay. I got to find where we're traveling back in time to. Hold please. Let's travel back in time to here. Here's our marginal product curve, right? And we remember our specialization and division of labor where I hired people and they actually started making more and more and more stuff. But then we reached that maximum. And then as I hired more and more people, what happened to their output? It decreases. We reach diminishing marginal returns. So think about my willingness to pay these workers on the diminishing marginal return side of the scale. What's going to happen to my willingness to pay these people? It's less and less and less because I'm getting less and less and less output out of each additional worker, right? So what is my demand curve for labor going to look like? Julian? What, loud and proud? What's that? Yes, my demand curve for labor is going to be, well, initially it would go up, wouldn't it? Let's make an assumption that everybody's smart enough to hire the workers that get better and better and better, right? And the only decision we have to make is when to stop hiring them when they are getting worse and worse and worse. So what does our demand curve for labor look like? A downsloping line. It looks almost like a demand curve. And this is a little bit of a weird, what do you think the M stands for? Okay, and I'm going to hire workers based on the amount of money they bring in for me. What's the R? What's the R? Revenue. Yes, because I'm hiring them based on how much money they bring in. What's money coming in? Revenue. So this is the extra revenue from the products that are generated. MRP, marginal revenue product. I'll put those down here at the bottom. MRC equals marginal resource cost. MRP equals marginal. What about your face? Better? Better get me a bucket. I'm going to throw up. Tell us something we know, Jada.
We're gonna produce the manifest.
What's our profit maximizing rule for a labor market? Our profit maximizing rule for the labor market is where MRP equals MRC. And why is that true, everybody? Take a look at this unit right here. Let's call it Q1. Does Q1 make me happy? Individually, does Q1 make me happy? Not the happiest, but does it make me happy? It makes me happy because MRP, or marginal revenue product, money generated by that employee, is greater than MRC, how much it costs me. So in essence, I hired that worker for $5 and they produced $12 worth of output. Do I like that person? Sure enough. Q2, do I like that person? I do like that person. I like that person because, again, MRP, or marginal revenue product, is greater than MRC, or marginal resource cost. I hired that person for $5 and they gave me $7 worth of output. Am I happy with that person? Sure enough. Sure enough, good to see you, but it's time to go. Do I like that person? Why don't I like that person? My marginal resource cost is greater than my marginal revenue product. I hired Sarah for $5 an hour and she produced $2 an hour worth of output. I'm sorry? Sarah produced significant amounts of output and stole much of the output, leaving only $2 worth of output for sale. So that's good for Sarah, but not for me, who hired Sarah. Sarah, Sarah, storms are brewing in your eyes. Is that the song you were thinking of earlier? The one I literally was just singing. Mashugana. All right. That right there is a perfectly competitive labor market. Did that seem challenging? Does everybody see how it's like, in essence, the exact opposite of a perfectly competitive product market? Here we have a horizontal supply curve and a downsloping demand curve. What do we see in a perfectly competitive product market? A horizontal demand curve and an upsloping supply curve. Marginal cost as supply. Goatmar.
So why do you want to produce it before not actually getting any extra?
How would I know that I had collected all of the positive workers if I stop hiring before I get to zero? Imagine walking down the street and running into $100 bill. You're happy, aren't you? You keep walking down the street, you run into a 50. You're happy, aren't you? You're walking down the street, you run into a 20 along the same path. Would you stop at that point and go do whatever else you were doing? What would you do? Why would you keep going? To see if there's anything else to collect. If I stop here, even though I'm happy with this person, right? What might I be missing out on? I might be missing out on more profits that I can make, right? So this, in essence, in that example, here's the $100 bill. Here's a $20 bill. Is it possible there's a $10 bill down the road? Let's keep going and find out. I keep going until, boy, I got to zero. There's nothing else to gain by doing this walk. What am I going to do now? I'm going to quit. Does that make sense, Omar? These are good units to produce. What you want to, or good workers to hire in this case. What you want to do is you want to collect all of the good workers that you can possibly collect. We don't want to leave a good worker on the sidelines if they can make us profit. Hire all of the good ones until you get to Saratel. Okay. That's kind of fun, isn't it? Because it's the opposite. Yes.
There's a competition, and you're looking at them in regards to it, and then you apply, you use it.
Yes. Yeah, that's exactly what would happen, right? What would happen if the price of the product in this marketplace increased? If the price of the product in the marketplace increased, I guess we would have to examine why it changed, right? There's a P there, which means what type of market is this? Product market or labor market? Product. P for, isn't that nice? P for price, P for product market. All right. So let's say, just for grins, this is our product market, right? And we see this happen. Does society want more of this stuff or less of this stuff? Society wants more of that stuff, right? What's going to happen to the demand for labor in this marketplace? It's going to increase. That's right. It's going to increase. Each individual firm is going to see an increase in the demand for labor. So in essence, what would happen there is this would happen initially, right? There's my firm with an increased demand for labor. They're going to hire more workers at the exact same wage rate if they're the first actor there, right? Eventually, what's going to happen in the marketplace? When everybody catches up, demand in the entire marketplace is going to shift outwards. What happens to wage rates? And once those wage rates increase, quantity demanded for labor shifts backwards a little bit, right? But overall, are we still producing more than we did before? We went from here to here. Good stuff, right? So that is how changes in a product market can create changes in a factor market. Factor meaning factor of production in this case, right? Labor being a factor of production. Okay. That is, we're going to do a couple practice problems with that after I show you one more graph, because this one's fun because it's got a fun name. A single seller of a good is called a single seller of a good is called a monopoly, okay? A single buyer of a resource is called
Monopsony.
monopsony. No snot in there. Monopsony. What? And because there's only one buyer in the marketplace, the market and the firm are lo mismo. The same. That means the same for all you non-Spanish speakers like me. Can we all agree that the demand curve for labor is going to look exactly the same, because at lower wage rates, firms will hire more people? Is that a true statement? Okay. So what's that? Yes. How can we tell it's labor markets? Because of the W, right? Wage weight. Now, here's the thing. Are you ready for the thing? Let's go back to something we discussed earlier. And let me label it properly and not pull a Gillen, as I like to call it. Hey, do you guys want to hear something funny? This is pretty great. On the exam that we took the other day, Gillen got 23 out of 24 points on the free response section. It was a pretty great job, like kind of nailed it. The one point he missed was he redrew the game theory, like Punnett square thing perfectly. Had the numbers exactly right, forgot to put dollar signs next to them. And so he didn't get the point for that. Isn't that great? Gillen, that didn't make you mad at all, did it? Scale, Sarah, always a scale, never curved. You guys should be happy that it wasn't curved because a couple of people got 44 out of 44. If I offered you guys $0 to come and work for me, how many of you would be likely to come and work for me? No one, no one. There's a very good chance that I would get 0 workers offering $0, right? So what is my total resource cost in that case? How much am I spending on labor? 0. You guys are nailing the math today. I love it. So let's assume that if I want to hire workers and I can't get anybody at $0, what am I going to have to do? Raise the wage rate. I'm going to have to raise the wage rate. Okay. So I raise it to $1, and I find that because Omar is such a magnanimous human being, Omar says, you know what? I'm going to come and work for you for $1 an hour. And I say, Omar, what a delight. And that's great. And how much is my total resource bill at this point? $1. Again, HL here. All right. It done been nailed. If I want to hire another worker, what am I going to have to do? It does get challenging to say, doesn't it, Jada? Raise the wage rate, and I get 2 workers. What's my total resource cost? $4, because 2 times 2 is 4. No, that's it. You got to pay everybody the same wage rate, right? If you can perfectly wage discriminate, then yes, you could keep that first person at $1 and pay the second person $2. If you ever work for Publix, Publix has a rule that you are not allowed to discuss your wage or salary with another employee. If they know that you are doing that, you can be fired for that. And this is the reason right here, because they want to pay you individually as low as they possibly can. And they don't want 2 people standing next to each other stacking fruit in the area where they stack fruit, with one person making $17 an hour and another one making $9, because that could create some issues, couldn't it? So they have a rule that says you can't discuss your wage or salary with another person. Kind of fun, isn't it? Who does that give price control to? Publix. Okay. So if I want to hire a 3rd worker, what do I have to do? Raise the wage rate. Jack, how much am I spending now? Excellent. Nailed it. I think you guys can remember how to fill this out, right? Don't forget your dollar signs. All right. If we have a total resource cost, is there any way that we could figure out the change in resource cost as I hire 1 additional unit of labor? Yeah. Well, let's see. What do we call the extra money to hire a new resource? Marginal resource cost. That's correct. Ooh, do you see where this is going, Jada? You can sense it, can't you? What's my MRC when I hire my first worker? $1. Okay, so I'm going to put quantity of labor here. 1, 2, 3, 4, 5, 6. What is my marginal resource cost when I hire my second unit of labor? $3. Wait a minute. On that last graph that we saw in the perfectly competitive market, I paid all my workers the exact same amount. So MRC was a constant horizontal straight line. In this case, in order to hire more units of labor, what do I have to do? I have to raise the wage rate, which means that every time I raise the wage rate, my marginal resource cost is going to go up faster. I raised my wage rate by $1. Marginal resource cost went up by $2. I wonder if we've seen anything like this before. Remember when we first did the monopoly demand curve? In order to sell more units of a good, what do I have to do? Lower the price. Every time I lower the price by 1, marginal revenue drops by 2. That's why the marginal revenue curve slopes down faster than demand. Do you see what's happening here? It's in essence just the reverse. When I want to hire my third worker, how much extra resource cost do I take on? $5. When I hire my fourth worker, how much extra resource cost do I take on? $7. How about when I hire my fifth worker? $9. How about my sixth worker? $11. Okay, so I want you to graph the labor supply curve. What is a labor supply curve? How many people are willing and able to work at each individual wage rate? How many people are willing and able to work at each individual wage rate? Draw that curve on the graph. It's an upsloping line with a slope of 1. Okay, don't let this be the hard part. There's my supply curve. However, in this case, is my marginal resource cost exactly the same as supply? It is not. Marginal resource cost increases faster than supply, doesn't it? Because every time I raise the wage rate by 1, marginal resource cost goes up by 2. What is going to be the slope of MRC? Is it going to be more steep or less steep? More
Like
steep.
twice as steep.
It's going to be twice as steep. Look at Hirsch. There's our MRC curve. Now, let's go to noted superstar, Jada Carter. Jada, where is this firm going to choose to hire labor? Product. There we go. They are going to hire where MRP equals MRC. Right here. Let's identify that quantity. So there's our profit maximizing quantity of labor. Good. How much are those people going to earn? Where do I find wages on this particular set of curves? Which line? Demand? MRC? Supply? Which one of those has a wage rate associated with it? Loud and proud, Jada. What is the supply curve, but how many people are willing and able to work at a given wage rate, right? So in order to find the wage rate that is going to be paid to these workers, we have to go down to the supply curve, and that's where we find our wage rate. If we think about that relative to the monopoly, how did we find the monopoly profit max? We found MR equals MC, and then we went up to the demand curve to find the price. Remember, I said labor markets are just opposite of product markets. How do we find profit max? I find MRC equals MRP. And then to find the wage rate, I go down to the supply curve. All right. So here is also a place where we can see inefficiency in the marketplace. Look at what this market power is doing for this firm, right? Here's the wage rate I'm paying down here, correct? There's MRP. MRP, again, is the extra revenue generated by hiring a new worker. This worker is generating this much revenue. What is the company paying them to do that? That wage rate way down there. What's the difference between those things? That's market power and profits, right? From society's perspective, where would we prefer that wage rates and quantity of labor be? Right here where supply and demand cross. So there's our quantity of allocative efficiency. There is our allocatively efficient wage rate. Are there workers who would love to be in this marketplace that are being blocked out of the marketplace by monopsony power? Yes. Where are they? Right there. Those workers right there would love to work, except the firm won't hire them because they will lose the money. Because of the monopsony power of the firm, they hire fewer workers than society wants hired, and they pay them a smaller wage. And what do you imagine we're going to call this area right here? Yes, that is a triangle of inefficiency or dead weight loss. This is kind of fun, isn't it? In that it's literally exactly the same principles as the monopoly, only backwards. Upside down. It's super sweet. Is it really? Not quite. Okay. Upside down and mirrored. No. Okay. Do you feel like that was a reasonable preview of labor markets? That when you see it again, you might have a better understanding of it? I think you will. I have a lot of faith in you. You are good human beings. Hold, please. Let me show you what a labor market question on the AP exam might look like. We can do one together. It'll be fun. I think it'll be fun. Of course, maybe my ideas of fun are different than yours. Is that possible? I think it is. Let's see, AP micro question list. There it is. Processing. Cobb County Technology preparing you for the challenges of the 1990s. Okay, let's take a look here. Here's all the questions from the past few years. What have they been focusing on recently? Monopolies, right? And you could probably say, well, there's no way they're going to give another monopoly question, but I bet people said that for the last 3 years, didn't they? All right, where's a labor market question? Here's one. 2008, is that a B? Yes, it is. 2008 B. Brett. Stretch out, whatever, Jack, you know, just make yourself comfortable, you know? Your face hurt? It's killing me too. All right. Euban, we keeping you up?
Yes.
Oh, good. Okay. I'm sure it's the hour, not the company, right?
Yep.
I did. I did. Okay, here is how you might see a labor market question on the AP exam. I think what I might do is point this. No, I'm not going to. All right. So let's take a look and read the directions. As you may or may not know, reading the directions is always a good thing because there's always information in there that is going to be necessary to you. GW produces and sells hats in a perfectly competitive market at a price of $2 per hat. It's good to know because then we can figure out how much money each individual worker is going to make for us. Because if they make 10 hats and I can sell each of those hats for $2, how much did that worker make for me? 10 times 2, everybody. 20. Good. Okay. Assume that labor is the only variable input and the wage rate is $15 per unit of labor per day. The table below shows GW's short run production function. Production function, no, that's different. Hold please. Are you holding? Identify. What is that? That's screen 4. Junction, what's your function? Hooking up words and phrases and clauses. All right, so generally speaking, you are going to likely need a second column of some description whenever you see a labor market question. I can see I don't have a camera on, but that's okay. Now, after which worker do diminishing marginal returns begin? That's a great question. And how are we going to find out? We are going to find out by actually going and finding the marginal changes for each of these workers. Let's do it. Let's find it. Okay. So what is my marginal change in output for worker number 1? 10. So 10. There's my marginal output, right? So we could label this MP that way. What's my marginal output for my second worker? 16. Was that increasing or decreasing? You guys are nailing this. What's my marginal output? And what just happened? So which worker started diminishing marginal returns? Our third worker. Yes. So, sure, there you go, done. Julie. I think 3 is the one they're looking for. I don't know. This is worded stupid, and I remember them changing the way they word these questions because of that. After which worker? So maybe after worker 2. Yeah, okay, I'll buy that. Let's undo. Let's undo again. So after worker 2. Okay. All right, what is the marginal output of the fourth worker? 8. What is the marginal output of the fifth worker? And then what is the marginal output of serotonin? 3. Okay, good. All right. What's wrong with you guys? All right, so calculate the marginal physical product. Marginal physical product is literally how much physical output did our fifth worker create. So what did we get when we hired our fifth worker? 5 extra units. So the answer to part B is 5. Yes, if it says calculate, show your work. So what you want to do right there is 49 minus 44 equals 5. I didn't really need this. Okay, so there you go. Calculate the marginal revenue product of the third worker. Marginal revenue product is how much extra money is coming in from the production of this worker. So how many extra hats do I get from the third worker? I get 10 extra hats, correct? How much can I sell each of those hats for? $2. So I get 10 hats. Okay, what just happened? Oh, I know what happened. I get 10 hats times $2. Can somebody do the math for me? 20. Excellent. Well done. Sarah, couldn't you have your face in your phone at home? Like, okay. How many workers will GW hire to maximize profit? Let's ask ourselves a question. Why would you hire a worker? Because the revenue they bring in is greater than the money that you have to pay them out, correct? How much do we have to pay these workers? $15, okay? So worker one gives us 10 units. That's $20 worth of value, right? Would you hire someone for $15 if they gave you $20 worth of value? Yes. Worker two, 16 units of output. They're going to create $32 worth of value. Would you pay someone $15 to create $32 worth of value? Yes. Are we hiring worker three? Pay them 15 to get 20. Yes. Are we hiring worker four? Pay them 15 to get 16. Are we hiring worker five? Right. We would never pay someone $15 to get $10 worth of output. So worker one, good. Worker two, good. Worker three, good. Worker four, good. Worker five, okay. Excellent. So there we go. Note it doesn't say calculate, explain, tell why. If it doesn't ask for it, don't do it. You guys may have heard that on AP exams sometimes, as long as the correct answer is there, you get credit for it. Econ is a different animal in this particular case. You can do something in econ and oddly enough in history as well on short answer. That's called poisoning your answer. You can't do it in AP government. In AP Gov, if you put the correct answer amongst a list of 27 other wrong answers, you still get the point. Right. It's dumb. But in econ, you can poison your answer by putting incorrect information alongside correct information. Okay. So just be cautious. If they don't ask for an explanation, don't provide one because you can poison the correct answer. Okay. If GW has fixed costs equal to $20, what will the company's short-run economic profits be from hiring 2 workers? All right, let's find out. Okay, so let's look at total variable cost. They tell us that labor is the only variable cost, right? If I hire 2 workers, how much are my variable costs going to be? $30. All right. They've told me what my fixed costs are. What are my fixed costs? Anybody? 20. Literally right in the question. So my total cost comes out to be $50. Okay. And if I hire 2 workers, what is the output of 2 workers? 26 hats is the output of 2 workers. $2 per hat. So how much money am I bringing in? Okay, so revenue equals 52. All right. So if you spend $50 and bring in $52, what is your level of profit? You guys are winners. I want my $2. All right. No fans of 80s movies here? Yes. If you just put $2, it's fine, because it doesn't say calculate. If it said calculate, show your work. If the price of hats increases, what will happen to the number of workers hired in the short run? And why will it increase? Loud and proud, Gillen. I agree. Okay, so let's take a look at we'll pick worker number 3, right? Worker number 3 gave us 10 extra hats, right? At $2 a hat, what was worker number 3's MRP? $20. But at $3 a hat, what's worker number 3's MRP now? $30. So if worker number 3 is giving me $30 worth of output instead of $20 worth of output, aren't I more willing and able to hire workers in this case? And that's exactly why we would want to hire more. If the price of the product goes up in the marketplace, in essence, we're saying because of demand in this case, we will want more workers because my workers are now more valuable. All right. How much of that seemed challenging? None of it? I mean, seeing it for the first time might have been a challenge, right? But like process-wise, did any of that feel like it was really challenging or difficult? Okay, this is another one of those examples where you are identifying the idea that you're understanding the principles of econ and you are applying your ability to think like an economist in new ways. But since you can think in the correct way, applying it in new ways becomes incredibly easy. Okay, so in essence, all you're doing is applying the theories of econ that you've learned and understand completely to new situations. And all of this made sense to you because it just makes sense, right? Should we do another example just for grins? Let's do it. Let's do one more. And then we'll call it a day. What do you think? I did not. It will be a long video. That's fine. Nobody will watch the whole thing. It'll be good. 2006. Let's look at 2006. Hold, please. It was. I was almost, young then. No, absolutely not. How old was I in 2006? I'm 50. Sure am. Oh, that's so nice, Julian. I'm 85 at heart, right? Okay, here's another wonderful labor market. Do you guys want to try this on your own? Maybe do parts A and B. We'll do parts A and B in the next 94 seconds, and then we'll go over. You're having a party? Oh, part A. Oh, not part A. Okay, I get it. Wow. On your mark, get set. Good. Okay. Wait, is this even the labor market question? Who knows? What is the value of the firm's total fixed cost? It's $20. And how do we know that? I remember having you there. Thank you, Miss Offmar. That is correct. Miss Offmar is the name of the teacher in the Peanuts series that it's Miss Offmar. See, I bring a little bit more to the table every day, don't I? What about your face? Of course. All right, so yes, the fixed costs are the costs that are associated with 0 units of output. Calculate the marginal cost of producing the first unit of output. What is it? $7. 7 balloons. All right, good. Do part C. I'm dying. Don't celebrate that, Jada.
But we're all dying anyway. So it's
Just at different rates, right? At 15. Okay, so those, I think I did the math right on those. What's that? 1 to 2 is 11. Yeah, I thought I did the math right. I clearly did not. That is why I didn't take HL math. Oh my God, no, I wouldn't have taken an IB program. I never would have done the amount of work that you guys do. 0 chance. No chance at all. Anyway. If we receive $20 for our product indicate, would you make the first unit? How about the second unit? Would you create a unit for $11 if you got $20 back for it? Would you create a unit for $15 if you got $20 back for it? Would you create a unit for $19 if you got $20 back? How about $23? No. So we're going to make unit 1, 2, 3, 4, but not 5. Okay. The answer is just 4. Oh, explain how you determined your answer. Showing the math is an explanation in this case. Or if you wanted to explain it, use marginal cost and marginal revenue thinking, right? All of the units that you produce, marginal revenue exceeds marginal cost. But for the 5th unit, marginal cost exceeds marginal revenue. That would be a wonderful explanation. Oh, you want to throw it out there, Jenna? You don't want to try. Oh, okay. Now, given your results in part C, explain what will happen to the number of firms in the industry in the long run. Okay, we need to figure out if this firm is earning profits or losses, correct? How many units are they making? 4 units, okay? So their quantity, I totally get that one. Okay. Quantity equals 4. Price equals, well, how much can they get for each unit? $20. So what's revenue? So the revenue is $80. Excellent. Okay. Now, how much did it cost them to make those units?
$72. Or according to them, 75.
Okay, so is this firm earning economic profits, breaking even, or earning losses? Positive economic profits. If there are positive economic profits, what's going to happen in the long run? And there's your answer. More firms will enter the marketplace. It doesn't even say, oh, it does say explain. Because the firm is earning positive economic profits.
Increase because of time that
Mhm. Oh, look at that. Letter E, letter E, letter E, letter E. After D, before F, letter E. All right. Assume that this firm operates in a constant cost. Oh, look at that. See, that's where this constant cost industry comes in, meaning that no matter what their output is, their minimum average total cost stays the same. Okay. And has reached long run equilibrium. If the government imposes a per unit tax of $2, what will happen to the firm's profit maximizing output in the long run? Let's see, if we put a $2 per unit tax, will people buy more or less? Which means their profit maximizing output will, there you go. Done. Okay, I'm done. We will have class Monday, Tuesday, and I will do a review Wednesday morning because your exam is Wednesday afternoon. I have no, I don't pay attention. So make sure you take a look and see if you have any further questions, comments, concerns, worries, or feelings to bring with you to a review or to class. Ladies and gentlemen, this has been fun. Enjoy your afternoon. Now let's make like a baby and let's head out. Bye.
Thank you.